So on the previous two videos, we've just been simplifying radicals. Now we also need to be able to do math with radicals, actual math with radicals. Now what do I mean by math with radicals? Look at number 10 right here. It's 3 square root of 2 plus 5 square root of 2. That's simply combining like terms. What's the answer? 8 square root of 2. Because 3 plus 5 is 8. Right? Now it's a different story if you're multiplying. Multiplication, you could just rearrange it. Like on number 11, that would really be 4 times 3 times the square root of 3 times the square root of 2. Now we know we could actually multiply radicals, and that would give you the square root of 6 inside the radical. So what's our final answer for this number 11? 12 square root of 6. Piece of cake. All right, let's move on to the next one here. We have, could we actually add the square root of 3 plus square root of 12? No, it have to be exactly the same radical in order for you to be able to add them. So we can't add them yet. But if we look at the square root of 12, could we actually simplify that? Yes, we could. Let me zoom in on the square root of 12, and let me rewrite it as 4 times 3, and then split the root. What does that become? 2 square root of 3. Okay, and that is the positive comes down. That's a positive 2 square root of 3. And let me go over here to this next one. It says square root of 27. I could actually change that to a 9 times 3, which means that when I split the root, I'm going to end up with 3 square root of 3, right? And I'm also going to bring down this minus sign and put it right in front. Does that make sense? So these three things that I could not add together, all of a sudden now I am able to add together. This is really like an invisible one right here. It's like 1 square root of 3 plus 2 square root of 3. How much is that so far? That's 3 square roots of 3. And then take away 3 square roots of 3. Final answer actually is 0 right here. Cero. Cero entero. Wait. Pause. Number 13, we're doing math with radicals now. The first part was simplifying, now we're doing some math. Right here we're just going to distribute the square root of 2 times 2. That's like saying x times 2. What's x times 2? 2x. But right here, square root of 2 times 2 is 2 of those square roots of 2. See what I'm saying? The square root of 2 times negative square root of 8. Well, first of all, a positive times a negative is a negative. And the square root of 2 times the square root of 8, you could actually multiply those together, and you get the square root of 16. But you could actually do the square root of 16. So you really get 2 square root of 2 minus 4. Not only that, guys, whenever you get a binomial with the radical in it, it's always a better idea to write your real number first, or your integer first, and your radical second. Okay? So this is the best answer right there. Negative 4 plus 2 square root of 2. Let's move on to number 14. Number 14 has a binomial, but both parts are radicals. And we're going to square it. Okay, so how do we do that? You're going to write it twice. And then you're going to distribute. So I want to distribute, what's square root of 2 times the square root of 2? That's the square root of 4, but it becomes the nice, beautiful number 2. I don't know, maybe we should actually show our work here. Let me write it as a square root of 4. Why not? The square root of 4. Okay, how about the square root of 2 times negative square root of 3? That's going to be negative square root of 6. Okay? And what if I go negative square root of 3 times positive square root of 2? That's going to be negative square root of 6. Again, because a negative times a positive is a negative. Yay? Okay, and then at the very end, we're going to go negative square root of 3 times negative square root of 3. That's going to be positive square root of 9. So let's simplify anything else that we could. For example, the middle terms, that's a negative square root of 6. That's a negative square root of 6. That's like saying you owe one of these guys, you owe another one of those guys. You're going to owe two of those guys. Make sense? Combining like terms. And then you could also take the square root of 4 and rewrite it as the nice beautiful number 2. And you could also take the square root of 9 and write it as a nice beautiful number 3. So our final answer for number 14 should be the real numbers first. That's going to be 2 plus 3. That's equal to 5. And the radical part second, minus 2 square root of 6. Final answer right there. Through number 15 right here, it says parentheses 2 square root of 3 squared. 2 square root of 3 squared. A lot of these questions on this review are straight from the homework. So you'll see this on the homework also. The way to do this one, this is not a binomial. This is just 2 square root of 3, which is really 2 times square root of 3, and then squared, which means times itself. So we really have is 2 square root of 3 times 2 square root of 3. And let's do the coefficients, the nice numbers first. The 2 times 2, that would be 4. And what would the square root of 3 times the square root of 3 be? 9. Square root of 9. And what's the square root of 9 really? So you really have 4 times 3. So the final answer here would be 12. Now maybe I'm going too fast, but when you watch it again on the video, hit pause after each step until you understand each step. And there's going to be one more final section on the quiz tomorrow. You're going to have these exact instructions. Change the following radicals to rationals. Without these instructions, if I told you to simplify, you would leave them exactly the way they are, because these are technically already simplified. But because the instructions say to change to a rational, actually it should say change the following radicals to rational exponents. That's my bad right there. Rational exponents. All right, so number 16, what would it be? X to the 2/3. Man, it's like 3 points. That's it. That's it. Now, you wouldn't normally do that because 2/3, you can't reduce it. You can't simplify 2/3. You would normally just leave it as the radical, the third root of x to the second. Now, number 17, what does that become? 8/9 power, right? It's not the fraction 8/9. It's the fraction as a power. It's a rational exponent. That's your answer for number 17. And that's it. Now let's move on to this other one. It says change the following rational exponents to radicals. Okay, what would number 18 become as a radical? No. Fourth root of x to the third. It's always power over root. The power's on top, the root's on the bottom. So as you're reading, it says the fourth root of x to the power of 3. How about number 19? The fifth root of x to the fourth.